This is a long periodic table and it has that S, P, D and F block element. This is the S block elements. This is the D block elements. This is the P block elements. And this is the F block elements. Out of this today, I'm going to discuss first on the P block elements and then D block elements. At first, you have to remember this S block elements and these P block elements, these together, that means group number 1 and 2 and 13, 14, 15, 16, 17, 18. This group contains the elements which is called the representative elements or main group elements. So, what is the representative elements? Representative elements is the elements belonging to the group number 1, 2, 13, 14, 15, 16, 17 and 18. Block elements, its general electronic configuration is NS2NP1 to NS2NP6. NS2NP1, that means here if you see for the boron, boron is the 2s2 2p1, carbon 2s2 2p2, nitrogen electronic configuration 2s2 2p3, and oxygen elements contain electronic configuration 2s2 2p4, fluorine electron configuration 2s2 2p5, and for the neon it is a noble gas, so its electron configuration 2s2 2p6. So in that way the electronic configuration, general configuration of for all p block elements starts from NS2 NP1 and the last elements in the group number 18, its general electron configuration is NS2 NP6. And at the end of the each period is a noble gas. These all group number 18, these all are the noble gas. And it has the closed valence shell because every orbitals is occupied. That means 1 s orbitals and 3 numbers of p orbitals occupied, and its general electron configuration is NS2 NP6. All the orbitals in the valence shell of the noble gases are completely filled by electrons, and it is very difficult to alter this stable arrangement by the addition or removal of electrons. That means in the group number 18, whatever elements is there is the noble gas, and these elements have completely filled orbitals by electrons, and that's why it is very difficult to add or to remove any electrons in its orbitals for the elements in group number 18. And this is noble gas exhibits very low chemical reactivity. That's why, because there is a very stable arrangement and it is very difficult to add or remove the electrons. That's why this noble gas have very low chemical reactivity. But from group 18, if you go before, that means preceding group number 16 and group number 17. Group number 17, it is called the halogen family, halogen elements family, and group 16, it starts with the oxygen, it is the chalcogens family. So these two groups, that means group number 16 and 17, these very important groups in respect of chemical reactivity. And these two groups, whatever the elements are there, they are called the non-metals, because it is they are not metals. So this group number 16 and group number 17 elements have highly negative electron gain enthalpies and readily add 1 or 2 electrons respectively to attain the stable noble gas configuration, because from the group number 16 oxygen, it has the 2s2 2p4. So if you add 2 electrons, then its configuration will be like the configuration, electron configuration of neon. That means 2s2 2p6. And similarly, for the fluorine, its configuration we know 2s2 2p5, and if you add 1 electron, this is the 2s2 2p6, which is the electron configuration of neon. And that's why these two groups, that means group number 16 and 17, that groups elements are very reactive. The non-metallic character, group 16 and 17 has non-metallic character, and it increases as we move from left to right across the period. That means from oxygen to fluorine if we go, or from sulfur to chlorine if you go, then the non-metallic characters will be increased for these elements. And the metallic character increases as we go down the group. That means if you consider the group number 16, that means from the oxygen to sulfur, that means metallic character will increase, and further metallic character will increase for selenium, and so on. For group number 17 also, fluorine has lowest metallic character and it will increase down the group. That means from fluorine to chlorine, if you go, then comparatively metallic character will be increased, and so on. Now discuss about the features of the D block elements. Right side this figure, if you see the D block elements, the D block elements, which is called the transition elements, and these are the elements of group number 3 to 12. That means the elements in group number 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12, these all are D block elements, and also it is called the transition elements. And these elements are characterized by the filling of inner d orbitals by electrons and are therefore referred to as D block elements. That means these 3d orbitals is the inner orbitals. That means outer shell, most outer shell in this case is the 4. That means quantum number, principal quantum number is 4. Then inner shell, it is the 3d. Because outer shell starts with the 4s. So inner shell is 3d. So these 3d orbitals, it has the 5 numbers orbitals. So 10 electrons it can accommodate. And that's why it is referred to as D block elements. The elements have the general outer electron configuration is n-1, d1 to 10, n s 0 to 2. That means you consider in the first case, so these D block elements has general outer electron configuration n-1, d1 to 10, n s 0 to 2. That means that this n-1, this is the inner shell. If outer shell designated by the n is nothing but the principal quantum number, and inner shell is the n-1. And these D block elements all are metals, and they form the colored ions, and exhibit variable valence. That means the number of oxidation states present for these elements, and it has the paramagnetism properties. Paramagnetic properties means it has the unpaired electrons, and these elements sometimes used as catalyst. This group number 12, that zinc, cadmium, mercury, it has the electronic configuration N-1 D10 NS2. That means for zinc, as for example, its electronic configuration is 3D10 4s2. And this group number 12 element, though it is D block element, but it doesn't show the most of the properties of the transition elements. Though this group number 12 belongs to the D block transition metals elements, but for this particular group number 12 metals doesn't show the property like transition elements. Transition metals form a bridge between the chemically active metals of the S block elements and the less active elements of group 13 and 14. If we remember that long periodic table, then extreme left side is the S block elements, and which belongs to the group number 1 and 2, and after that the D block elements, and after right side, extreme right side of this is the P block elements, and its group starts from the 13, 14, 15, 16, 17, 18. So these D block elements whose group starts from the 3, that means before that the S block elements whose group is 1 and 2, and D block elements right side is a group number 13 and 14. So these D block elements from the group number 3 to 12, it is the connecting from the S block elements and the group 13 and 14 groups elements. That means from the left side we have taken two numbers of group number 1 and group number 2, and from the right side two number of groups from P block, group number 13 and 14. So these D block elements connected by these groups number 1 and 2 from the left side, and from the right side group number 13 and 14. And then thus take their familiar name transition elements. That means transition metals form a bridge between the chemically active metals of S block elements and less active elements of groups number 13 and 14. That's why it is called the transition element.